Welcome back, guys. So in today's video we're going to try and build a backend, a serverless backend. So what we're going to try to build is a system in which users can post their code and then it's executed. So let me pull up the design. So let me zoom this in. No, let me zoom this out. Yeah. So if you've never heard of serverless computing, the most popular one is AWS Lambda, maybe Google Functions. So what Lambda does is run code without provisioning or managing servers, creating workloads aware cluster scaling logic, maintaining event integration, or managing runtimes. So run code for virtually any type of application or backend services. Just upload your code as zip file or container image, and Lambda automatically allocates compute, execution power, and runs your code. So we write Lambda function in Node.js, Python. So this is we are going to write a skeleton of such a thing. So AWS Lambda is works with some technology called Firecracker, micro VMs. You can check them out. I will include all the links to this in the video, and you can check it. But for us, for prototyping purposes, we are going to use Docker containers as our isolated small machines for running. No, let's look for Docker. Yeah, so we are going to use Docker containers to do a demo of this. So this is just a simple backend to help you understand how actually these serverless architectures or these serverless frameworks work. So let's jump into this. So what we are going to do is a user will upload a zip file of their code. What I'm going to build will support two languages, Golang and Python. So for Golang, you upload your code and the Go mod file, and then we provision a container, run it, and give back the output. So we are going to have an HTTP server in Go, so that one will help us create the routes, the submit route and the execute route. We are going to have Docker engine running behind the whole thing. So we are going to have a temporary directory where we extract the zip file. So as we said, the upload will happen through you'll zip your code. So an example, for a Python, you'll zip your Python file and the requirements.txt file, and then for Golang you'll zip your code and the Go mod file, and then we will detect the language, and then we generate a Docker file for you, and then build the image, and then we will store the image ID. For now we are going to just use an in-memory map to do this, and then whenever you call execute on your code, we will execute your code and return the output to the user. So for demo purposes, let me demonstrate to you what we are trying to build. So an example would be, we have this jokes API code. So as you can see, it's Python code. So we ensure that Docker is running, and our server is also running. So when you execute, when you call this API endpoint, let's call it, and I hope the image is still there. Yeah, we get an output of a joke. When we call it, we get an output of a joke. So I want to show you how this happens. Let me run it on repeat intervals of 3, and then we will, on my Docker desktop, I will come and try showing you this. So if you check here the containers, whenever it's invoked, you see a container appearing here and disappearing. Yeah, so whenever we invoke the endpoint, it spins up a container and runs. Yeah, you can see that, and you can see that. Yeah, so with that, let's jump onto our IDE and try and code this up from the beginning. So let me stop Postman first. Yeah. Let me name the directory YouTube Serverless, and then we open the ID there. So who will have that? Let me increase the font size so that yeah, let me take it to something like 14 and then 1.4, then apply, and there we go. So let me minimize this, and yeah, so let me close this up and we go to our IDE. So we are going to start with a makefile. Let me create makefile that will help us run things, and then obviously we need go mod init. Let's just name it YouTube Serverless, and we'll need a main file, main.go. Now makefile, we will need a way to run the whole project. So we'll have run, it will be go run main. Oh yeah, so let's also write the curl to submit as a file. Yeah, so we are going to write that, and then curl to execute. Yeah, let's see if all that is working well. Package main func main, and then we do fmt println welcome to serverless. Yeah, so that is working. So what are the packages that we are going to need? We are going to need a directory to store our templates. So, and then we are going to need a directory. We'll need a utils package, and then we will need a Docker package. So we will also need the handlers. So let's start with our templates are going to be YAML files. So I will have golang.yaml, and we'll have python.yaml. So I already prepared these YAML files, so I'm just going to copy and paste them here and then explain what's happening. So for Golang, we have this YAML file. So this is a YAML file. So we will read the Docker file. You see, we are getting, it's a multi-stage Docker build. So if you want to understand how to do multi-stage Docker builds in Golang, you can put it in the comments below, and I can work on a tutorial just for this. But for now, our tutorial is on writing this serverless infrastructure or serverless backends. So for our python.yaml, I already also prepared a python.yaml file, and there it is. So we have those two files. So let's go to our utils package. So the utils package will contain all the functions required to create the temporary directory, clean up, save the zip files, extract the zip files, detect, handler file, and all, and just about everything that could come here. So the first thing we are going to have here is a function to create the temporary directory. Let's call it create temp d, and it will take nothing, return a string and an error. So we are going to return os dot and then we are going to have that pattern zip extract, and then we are going to have a function to clean this up. And then we are going to if error is not equals to nil, we log the error. Let's get a better logging library, zero log. let's name it log so that it doesn't disappear on us. So going to log.info. And what we're going to do is go mod tidy to bring. So yeah, and then we also need a function to, let me get rid of this so that we have a big space. Let me, yeah, we also need a function to save the zip file. Yeah, and function to extract. If the error is nil, we return that. We check the error. If the error is nil, we return that. Let me bring that up. Then we defer. I'm using Copilot for the completion, so yeah, that's why you see me accepting Then now we extract. Oh, then now we, for file in range files, path is that, and then let me write this and then explain to you what's going on. Then we defer that output file dot close. As you continue, zip file.open. If there's an error, return an empty, and then we defer the zip.close. So we are shadowing some error. Let's name this error 1. Yeah, so errors inside the for loop, we've named them error 1 so that they are not shadowed. So what does this do? So it's a go function. We are extracting some zip file, and it accepts the zip path and the temporary directory where it's going to place those, and then it will return the path to the directory where the files are extracted, and maybe an error if there are any. So it creates a subdirectory and names it extracted inside the temp directory using the os.make directory. Sets the permissions, and then it's open the zip file, zip file.open reader, and then it iterates through the files while copying them to the temporary directory. That is what it does. So I think our utils package is almost complete. We will add functions to it as need arises. Yeah, so no, I said that we were supporting two languages, so we also need to detect which language we are dealing with. So we read the directory, and if file range is D, we continue switch file extension, we check the file extension, case.py, we return Python, and we return Golang. This is not really efficient, but will work for us for now, because a lot of files could be inside this that have different extensions. So this is something that I'm using right now, but I don't think it should stick. I think the user should know the language they are writing on, so that our request comes with the language, just like you do on Lambda. You choose your runtime. So that is an improvement that if people find this tutorial useful, we could go and put and when we see how we can scale it, make it do this with background workers, not just in a synchronous way. So if I get 1,000 views on this, I will create another video on how we could improve this, how we make it asynchronous and all that, and even put some persistent storage on the backend, so something like Postgres and all that. So give the video a thumbs up, and let's continue. So we've done that. I think now we can go to our Docker package. So what do we need to do with Docker? So this is where we need to pass the templates that we had here, and after passing, we copy the code that was unzipped. We copy the code that was unzipped inside the Docker template, the Docker image. Yeah, we copy the code that was zipped inside the Docker image and then build a Docker container. So yeah, that is what we need. And then even we'll also need to run the image when the invoke or execute handler is called. So that is what we how do we build those? So we'll need one build Docker image, and what we'll need a structure first. So type template is a struct, and it will have the field Docker file, which will be a string, but then it was YAML. So yeah, so as you see, Docker file, the YAML annotations. If you come to our YAML file, you see we've named it Docker file. So this is what we will pass, load the template into, so we can write the function to actually load the template now. So how do we load the template? We first of all determine the file to the template. So we've you see Golang, Python. So this function will take the language, and with that it will help us locate the template that we should load. So let's read the template os.read file, template file. If we have an error not equal to nil, what do? We'll return nil and return the message. Then we pass the YAML file. How do we do this? Create a variable template of the type template, and then we use a package in Go to pass the YAML file. So this package, let's name it Y so that it doesn't go away. So let's run go mod tidy to bring it in. Yeah, so we unmarshal. Now I know we don't need this Y. YAML.unmarshal. If error is nil, we return that. But then if everything is fine, we return a pointer to that. Yeah, so that is how we are going to load our template, and then we'll need to build the Docker image. So this is a helper function. I think we can put it down there and write our function to build the Docker image. Yeah, so you see, for our Docker file in Python, we have a placeholder here for a string. So you see the way you run Python, when running Python, you say Python 3, and then that file you're going to run. Python, that file you're going to run. So that is what we are doing here. If the language is Python, we pass in that handler file. But then if the language is Go, we don't need to do that. The Docker file contents will just be the contents in this Docker file, because you see for Go we have just a CMD handler and all that. So, and then we need to write the Docker file to the directory. So Docker file path, join that. Yeah, so we are writing to the Docker file contents into our Docker file, giving the permissions necessary, and then if failed, we are logging the error. We're almost done with this part. And then now, after we've written our Docker file, we need to build the image, build the Docker image. So we can call it Scrappy Serverless or YouTube Serverless. And then the language. So we are tagging the language. So our Python language, Python Docker file and Golang Docker file will not overwrite each other. And then we are going to exec. If you've used Docker before, you know Docker build -t, then the image tag, and then the directory. You see our build takes the directory, so we are going to give it the directory where the Docker file is. So when that is successful, we want to catch the output, the combined output, cmd.combine output. We want to catch this combined output, and because it will contain the image ID of the image build and tagged. So with this image ID, we are going to, with the image ID, we are going to call the execute function with the image ID. So that's why we need it. So if error is nil, we return that, and if everything goes fine, we look for the image ID, and then we will return the image ID. We can remove previous images, but let's return the image ID. This can come in part 2, because while I was trying out this, I found out that it hogs a lot of images when you run execute. So we could have a functionality of cleaning up after our repository and all that. So I think from here now we can write a function to extract the image IDs. Our output there from is wrong, so we will get the lines. How do we get that? We split the output at every given line, and then we range over for line in the range of these will be lines, then let this be line. For line in the range of line, we are going to check when you build Docker on your machine, you see the output is always written like something writing image, and then you start with something like SHA-256. So we are going to check which line contains those words. We can improve this later, but and then after we get that, so we've gotten the line, and then we are going to divide the lines we are going to get the field lines. So strings.fields line, and then we range over these parts. So yeah, with that, I think we can extract the image ID from this. So and then here we'll return if it doesn't return here, we'll return the error. What else do you need to build in this package? Yeah, we need to run the Docker container. Let me put that function just somewhere here. So the run function will take an image ID and return a string, the output. I think maybe we can return a JSON object, but let's return a string. And we are going to have we are going to add a flag here. So from the demo you saw our container, we were spinning up a container, and then after we get the output, we destroy it. So we are going to run it with the rm flag. So then we will capture the combined output. If error is nil, we are going to return nil, an empty string, and the error. If error is not, yeah, so we could modify this to return a JSON, but that can come later. I think that is part complete. So we could now build our let's go and build our main function. So I think this would be good if it was log. Hello serverless, and what are we going to do here? We will have our routes here, http dot let's have handlers dot yeah, and then execute, then yeah, so I think our handlers function are the ones left. So we come to our handlers package and do handlers. We want to first of all we'll have an image store. Which will be a map string of strings. So this one going to store image IDs and their image IDs by so we are going to generate functions, and each function is going to be mapped to an image, so that when we call execute with the function ID, it knows the image to pick, build a container from, and run. So first of all, let's write the logging middleware. Just a simple HTTP logger middleware, and then now we will write the submit handler. Let's run gomod-id to bring the UID package. Yeah, so we are only accepting 10 MBs max of files. So if you upload a file that is bigger than 10 MBs, it won't pass. And then we are getting the zip. We named it code, so we are getting it from there. And then we are using our utils to create a temporary directory, and then we defer clean up temporary directory. So after this is done and creating of the directory and all that is done, we clean it up. Then we save the zip file in the temporary directory, and extract zip and all that, and then image ID and all that we build. No, what happens after the extraction? We detect the programming language from the handler file. So this is where I was saying that instead of doing this, we could totally get rid of this, and then our users will tell us which language they are writing code in from the request. Yeah, so I could build that. So give it a thumbs up. Tell me in the comment section if you want to see how that is done. I'm planning to make this into an asynchronous API with background workers and all that. If you would want to see that, tell me in the comment section. So we've handled the error. Then now we need to build the image. We look for the error, and then now after the image is built successfully, we will store the image ID. Let's generate a function. Then let's do, so our image store. This can be persistent storage. So we could create a table in Postgres for this, or any database of choice, or even on so after that, let's write the data is okay header. I think we're almost done. Let's import from our serverless, from YouTube serverless. Let's import. So that is done, and let's see. Now it's a good time to see if our code compiles. Let me make run. Bind address is already in use. Let me remove those. And, make run. So as you can see, serverless system is running on port 8080. Let's work on the submit handler, the execute handler, the submit route, and see so this is a short one. We are going to have the execute handler. It's going to look for the function, but let's name it to function ID. It's going to look for the function ID in the query. Function ID is required. Then check our store if the Docker image is available for that function. Then run the container. And then we get the output and send back the output. As simple as that. As simple as that. So let's kill our server and see if it compiles. So to test this, we will need some Python code. Test.py. Let's have print hello serverless. Let's zip that. Zip test py.zip make submit zip file equals to test py.zip. Yeah, and we have a function ID being returned here. Let's see if we can execute execute function ID equals to that. Function ID is required. Let's see how. Yeah, why is it misbehaving? And we passed make execute fn equals no, we should do this. Function ID. Yeah, so we do this. Yeah, and you see, hello serverless world. This is what we had in our Python code. Let's try a more complicated Python file. Let's go to jokesapi.com and let's pick a joke. So this is how. Let's pick this code and paste it inside our. So for Jokes API, we are on free version. It doesn't require that, and we are going to remove all this. Yeah, and limit is not required here. But now we have a dependency called requests. So how are we going to? We are going to create a requirements.txt file. Inside the requirements.txt, we are going to include the requests package, and then we are going to zip so let's remove let's zip test.zip, and we are zipping test.py and requirements.txt, and then now we can submit. Test.zip, and then we have the function ID, and let's see, we can execute Yeah, and we get a joke. So the same can go for, you see, every time we execute, we get a totally different joke. And I want to show you how this is, let's pick this ID and go to Postman. Let's open Postman, and this became function ID, and we are going to paste there, that there, then we are going to execute, and it works. So let's repeat it on intervals, and then we can go to my Docker desktop so that I show you what's going on. So when you check Docker desktop, you see an image is being created, a container is being run every time it's called, and then it disappears. So here we have the serverless function is working well. So this is a skeleton of how serverless work. As I said, AWS uses Firecracker, and most serverless functions don't use Docker and these containers. They use micro VMs. You can read into that, and see you next time. Thank you, and please subscribe and share with somebody who will find this useful.